This video will show how to use the TI-84 to find a specific value. If you differentiate an equation and you want to find the value of that derivative at a specific x value, what you would do is on the calculator, first clear everything. So once you're here, push math. The eighth selection is for derivative. You can just push the number 8 or you can toggle down. I'm just going to push 8. It's now asking you, this is the derivative with respect to x. So I need an x there. I can push alpha, and this button over here has an x. Or the next way to do it, I'm trying to put in the equation for 2x to the third power. So first I need the number 2. And for x, I can just push this button here. And then to put an exponent, I push up arrow, and this is an exponent of 3. And then I want to put in where I want to find the derivative. And we can see over here that we want to find the derivative with x being minus 2. So going over, I toggle to the right. Then it's asking, I can put minus 2. So I push the minus button and 2. And then when I push enter, it tells me 24. It's always going to have some small value over here. You're just using the whole number part. I'll show that when we do a trig function in a minute. So the answer for this is 24. Let's go back and take a look over here. I'm going to do this by hand. And f prime of x, the first derivative, I bring the 3 to the front and multiply. So this is 6x and reduce the power by 1. I now want to find what the derivative is when x equals minus 2. So once I substitute in minus 2 for x in these two places, I'm going to go ahead and I'm going to first square the minus 2, which is times 4, and then finally 6 times 4 is 24, which agrees with our answer that we got on the calculator. So you're going to notice that it always has these extra digits past the decimal, but it's so small a difference from 24, just use the whole number. I'll give another example on it doing that. So I'm going to find the next one, and let's do math, then 8 for derivative. It's with respect to x. And for the derivative, what I'm going to do is I'm going to push sine of x. And I'm going to want to find the derivative of sine of x at x equals 0. So I'm going to put a 0 there. And the answer should be a 1. We'll take a look at why. So here we have the function f of x equals sine x. So f prime of x, the derivative of sine of x is cosine x. And then substituting in our 0 value. So let's take a look at the graph. I'll show you how to graph it on the calculator in a minute. For now, we'll go to Desmos. So here I've graphed y equals sine of x, and I'll overlay that with y equals cosine x. And here we see on the blue trace is cosine x, and at x equals 0, our answer should be 1. So now going back to the calculator, I will push enter. And it's again giving me a number really close to 1, but we just round this off. So the derivative of sine of x at x equals 0 is 1. In order to add the graph on the TI-84, since if you are in testing, you're not going to have access to Desmos online, you can use the TI-84 to check your answer also. So what we're doing here is I'm going to graph both sine of x and its derivative cosine x. And to do that, I click on the y equals button. And then I'm going to click sine x and close parentheses. And then I'm going to come down one and I'll put cosine x, and it'll put both of these on the same graph. So cosine x and close parentheses. And then you hit the graph button over here. Now it's not going to be very zoomed in. The red one is cosine. To zoom in, you can just push number 2. We see sine of x. And just so that you understand what's going on, the derivative of sine of x, the slope here is 1, the rise over the run. Cosine says that it's 1 at that point. Using the TI-84 for integration, I have to tell you right now that it has a limitation. It cannot calculate an indefinite integral. If you need a calculator, that'll do that and actually give you the algebra for an indefinite integral. Then the TI-Nspire can do that for you. And it's actually pretty close to the same price that the TI-84 was. So you might want to look into that one. Moving on, we can calculate a definite integral, which is give us an area under part of a curve, and we'll take a look at the graph of it as we're doing this. So, and when we integrate this, we substitute the 1 and the 3 in. So just as a review, a definite integral is when you have an interval from a to b, you find the antiderivative at b and subtract from that the antiderivative at a. So we'll do this one here. So to integrate 3x dx, what we do is we start with x, we increase the power by 1, we divide by that new power, and this 3 would have come to the front. So I simplify, and what I get is x to the third plus c. So what we get is 27 minus 1, which is 26. Now let's try it on the calculator. We're going to push the math button. 9 is for integration. Now it's asking us for the interval. The bottom number is going to be a 1. The top number, we push up arrow, that was a 3. And then for the function, here we're going to enter the 3x squared, up arrow, squared. And then we want to evaluate this with respect to x. And then we push enter, and we get 26, which is the same answer we got doing it by hand. So let's try one for integration with trig functions. So we're trying to find the integral of cosine x dx on the interval from 1 to 3. Well, the integral of cosine x, the antiderivative is sine of x. And then going from 1 to 3, this is sine of 3 minus sine of 1. And sine of 3 is, so sine of 3 is 0.14 minus, and sine of 1, I think, is 0.84. So sine of 1 is 0.84. I'm subtracting 0.84. So I get approximately minus 0.7. So let's go ahead and try that. So I'm going to push math. 9 is for integration. I'm going to put my interval from 1 up arrow 3. And then to the right, I am integrating cosine x. Push the x button, right arrow, and dx. And then when we push enter, we get minus 0.7. And as before, we have all of those extra digits past the decimal, but this is minus 0.7.